Hey guys, we're going to continue here with Chapter 7, Section 2, where we're going to be looking at multiplying powers with the same base. You'll want to pause and copy this all down right here. The first thing here is to multiply powers with the same base, you're going to add the exponents. Alright, so in algebra, that would be a and a are the base. They're the same, which means I would add m plus n. So as where a can't equal 0, m and n are rational numbers. So some examples of this would be 4 to the 1/3. Don't be freaked out about that fraction as an exponent. We'll look at those examples here in a minute. But 4 and 4 are the same base, so I would add these two exponents. Over here, b to the 7 times b to the negative 4 would be 7 plus negative 4, which means it's a b cubed. Here's why this works. Just a real quick example. If I have a squared times a to the third, a squared is the same thing as a times a. And if I'm multiplying that by a cubed is the same thing as a times a times a. The exponent tells you how many times a number is going to be a factor. Well, because this is all multiplication, these parentheses right here are not necessary. In other words, it's just multiplying straight through. So this whole thing is equal to a times a times a times a times a, which is the same thing as a to the number of times it's a factor, which is 1, 2, 3, 4, 5. So that's the same thing as a to the 5th. Well, think about the relationship here between 2 and 3 and then coming down here to the 5. How do you get from a 2 and a 3 to a 5? Well, you add them. So that's where this rule comes from. That's why it works. So let's keep going here. All right, daily funny. So, looks good. I love Pinterest fails. I don't love Pinterest, but I love Pinterest fails. I like those little sheep cupcakes. Nailed it. That's hilarious. All right, so multiplying powers. What is each expression written using each base only once? If it tells you to simplify, you get rid of the exponents. But if it's telling you to use the base or to write it with exponents, you don't do that. So here the bases are the same. So I add the exponents. So I get 4 plus 3, which is equal to 12 to the 7th. Yes, it's cool if you skip this and go straight from there to there. That is perfectly fine. I'm just showing you the logical steps that we take here. This one, it's a negative, so make sure that stays in parentheses. So I'd have negative 5 to the negative 2 plus 7, which is equal to negative 5 to the 5th. All right, so that's negative 5 to the 5th. That's all you're doing on these particular ones. Here's a couple for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, so here you go. I got 8 to the 9th and 5/10 to the negative 11th. So let's keep moving here. It says multiplying powers and algebraic expressions. What is the simplified form of each expression? On these, if they have coefficients, that's the number in front of the variables, we're going to rearrange this and multiply those coefficients. This is from the associative property, which we talked about earlier in the year. So I have z to the 5th times z to the negative 12th. Now I could go ahead and multiply 4 times 9, which is 36. And then that is z to the 5th plus the negative 12th, because it's the same base. And then I go ahead and add those values. So that's z to the negative 7th. All right, on this one over here, I'm going to rearrange this whole thing. Actually, let's go ahead. Don't ever, I should have on this last slide, but I don't want you to leave exponents that are negative. So if I get to this end part and there's a negative exponent, then we need to go ahead and move that to the bottom. So that's going to be 36 over z to the positive 7th, which is what you learned in that last section. So this is the simplified form of this. If it tells you to write it using negative exponents, then you would do that. Otherwise, if it asks you to simplify, you never ever leave an exponent in its negative form. All right, so here I got some things. I'm going to rearrange this so that I have the 2 times the 9 times the 3 times a. I'm going to go ahead and write that one as a to the 1st times a squared times b to the 4th. Now I have some things that I could do here. I have 2 times 9 times 3. I'm going to do 2 times 3 first, which is 6 times 9, which makes it 54. Here I have 1 plus 2, so that's a to the third, and then just b to the fourth stays the same. All right, so that one is 54a cubed b to the fourth. Here's a few for you to try. The answer will be up in 3, 2, 1. All right, so here are the answers I got. So check these against what you have, and if you didn't get them right, go back and try to find your mistake. Let's keep moving here. All right, so multiplying with scientific notation. It says the speed of light is about 3 times 10 to the 8th meters per second. How far would a beam of light travel in 8.64 times 10 to the 4 seconds? This is how many seconds are in a day, in one day. So to find this, if it goes that per second, and this is how many seconds there are, you're going to multiply these two things. So I have 3 times 10 to the 8th. Remember, scientific notation is used to write out really large or really small numbers. So I'm going to multiply these two things. Now, doing similar to what we were doing just a second ago, I'm going to rearrange these so that I have 3 times 8.64. And then I'm going to write my powers of 10 next to each other because they have the same base. Now what I do from this point forward is I'm going to multiply these two, and then I'm going to multiply these two. So first I have 3 times 8.64, which equals 25.92, times 10 to the, I have the 8 plus the 4 is 10 to the 12th. Now, this is not in scientific notation because that first number has to be between 1 and 10, and that's bigger than 10. So I need to rewrite this in scientific notation. So I'm going to have 2. I need to move the decimal to the left 1. To write this number in scientific notation, it would be 2.592 times 10 to the first, but I still have this times 10 to the 12th. All right, so this is between 1 and 10, but I have 2 powers of 10s that I need to go ahead and multiply, which means because their bases are the same, I'm just going to add their exponents. So it's that times 10 to the 13th. So that is how you multiply with scientific notation. Make sure you take your time on writing the notes on this one and really try to understand it, because this is one where people overcomplicate it. So make sure you're paying attention here. All right, so here's one for you to try. The answer will be up in 3, 2, 1. All right, so here's what I got. 2.4895 times 10 to the 7th. So let's keep moving here. All right, so it says simplifying expressions with rational exponents. Now, there's a couple ways to look at this. We haven't talked about the radicals yet, but we will. But for now, if you have an exponent, then the way that you read this is the number that when multiplied by itself 4 times. It's kind of the opposite of what 81 to the 4th would mean. 81 to the 4th would mean 81 as a factor 4 times. 81 to the 1/4 means what number is a factor 4 times that equals 81. Okay, so we have to think on this one a little bit. One of the easier ways to maybe do this sometimes is to do the prime factorization and just see if there's anything that happens. So 81, you should notice, is a power of 9, or 9. And 9 are both perfect squares. That get me to 3 and 3. So the question is, what number does 81, can 81 be multiplied, or what number can be multiplied by itself 4 times that equals 81? So in this case, it is, well, 1, 2, 3, 4. So 3 to the 4th is 81. So 81 to the 1/4 is equal to 3. 81 raised to the 1/4. And it is possible to put this in your calculator. You could raise a number, you'd hit the 8 key, and then you'd hit the 1 key, and then you'd hit the key that looks like a little house. All right, so it looks like this. And then you would do the parenthesis key, and then you do 1, and then that A, I always call it the ABC key, so A/BC, this key, then 4, and then your close parenthesis. And if you hit that, it will go ahead and solve that for you, which is not a bad way to do this. All right, so here's one for a couple for you to try. Go ahead. The answer will be up in 3, 2, 1. All right, so for this one I got 2, and that one I got 3. If you didn't get that, you need to go back and check on it. All right, so simplifying expressions with rational exponents. Notice here it's not a 1 here anymore. It's a little bit different. So the way that you could read this is I have 3 halves. In other words, 64 to the 3 halves. Again, we're going to look at these later when we talk about radicals and radical expressions, but for now we're just going to think of it this way. 64 is the same thing as 64 to the 1/2 times 64 to the 1/2, because remember, if the bases are the same, then I would add the exponents. Well, 1/2 plus 1/2 plus 1/2 is 3 halves. So here I have 64 to the 1/2 3 times. Well, what number multiplied by itself equals 64? Well, that's going to be 8. So I have 8 times 8 times 8, which is equal to 512. So 64 to the 3 halves is 512. I know these are kind of weird looking and confusing. We're going to spend more time on this, so just bear with me for now. Here's one for you to try. Answers will be up in 3, 2, 1. All right, so here are the answers I got. Hopefully you got the same thing. If not, go back and check your work. That's it for today, so hopefully you took good notes. I will see you in class.